Here's a great example of how the chronology rule can not just help you find answers, but help you avoid wrong answers. So this is a no-line reference question. There's no line that they tell us to look at specifically. But because it's at the end of the passage, we should, or it's the last question, we should assume the answer is near the end of the passage. And that's key, because a lot of people think that this is somehow like a summary question, that it's about the main ideas of the entire passage. No. They put those first. Those are going to be at the beginning of the questions, and we're supposed to save those for last, but that's where those main idea questions live. This is not about the main idea. This is about one very specific idea that comes near the end of the passage. So if we, for number 50 and 51, we were looking at all these lines here for our line references. So, and this was the one that was actually the right answer, we would expect the answer to 52 to be in that same zone. Probably after it, but amongst those lines at the very least. And the key here is that there are a lot of people in this passage. There's this guy Volkov, who we're being asked about. But there's also other stuff about these guys Haddock and Sievers. And so what they're trying to do with this question is to make you think it's just about the overall passage. And then you're going to start looking in the wrong places. This is about this guy's experiment. So if you look at the other people, you're going to get this wrong. So we need to make sure we're looking in the right place where they talk about Volkov, which is this last paragraph. And what do they say? Well, so he's doing his experiment, blah, blah, blah. It's electricity. That test the model. They rigged up very fine electrodes and applied an electric current to the lobes of the trap. This made the trap close without any direct touch of its hairs. They didn't measure calcium. The current likely led to increases. When they modified this experiment by altering the amount of electrical current, Volkov could determine the exact electrical charge needed for the trap to close. As long as 14 microcoulombs, a tiny bit more than the static electricity generated by rubbing two balloons together, flowed between the two electrodes, the trap closed. This could come as one large burst or as a series of smaller charges within 20 seconds. If it took longer than 20 seconds to accumulate the total charge, the trap would remain open. So I read it fast. I didn't read for detail. It's about electricity. That's all I care about. Charge, electrode, current. Lots of words have to do with electricity. So now let's look for that in our answers. A, mathematical models to predict the electrical charge required to close the Venus flytrap. Well, electrical charge sounds pretty good. But he's not using mathematical models. He's zapping the plant with electricity. He's not predicting it. He's doing it. He's zapping them. So there's no models here. Analysis of data collected from previous researchers' work involving the Venus flytrap's response to electricity. Well, the whole point of this guy is that he is testing previous researchers' theories. Volkov is testing Haddock and Sievers' model. However, he's not analyzing their data. They didn't do this experiment. This is a different experiment that tests the theory. So this is a very specific choice. It's not data. He's analyzing their work, maybe. He's analyzing their theory, but they don't have data. They didn't do this experiment. So that's not right. It's a different experiment. C, he's using information obtained from monitoring the Venus flytrap's response to varying amounts of electric current. Yeah, that matches pretty nicely with my very dumb summary of what's going on. Let's just look at D. Published theories of scientists who developed earlier models of the Venus flytrap. Well, he's definitely talking about a theory, but notice the concentration of words in this paragraph, right? I mean, it's maybe they say at the beginning that he's testing someone else's model, but the rest of the paragraph, repeated again and again and again and again, is that the electric current is what he's using as part of his experiment. So, when they say what is the most extensive, they mean like what's repeated the most. Well, they're very clearly talking about the electric current much, much more. So maybe this D is like a little bit true, but the question wants us to take into account how often they talk about whatever he's using and how often he uses it. So C is definitely in a much higher concentration. So that's what we should go with. And remember, that's just a general rule of thumb for any question that talks about like main ideas, whether it's the main idea of a paragraph or the main idea of the whole passage. Main ideas are repeated ideas. The more something is repeated, the more confident you can be that it's an important idea, and that's exactly what this question wants from us. So trust the numbers. If something's repeated that much, it's probably important.